Man, it's such a beautiful day doing some tables hurt. Well, I guess it's time to talk about ratio tables. So, let's review. We know ratios compare two things. Like the amount of push-ups I could do to sit-ups I could do. And now we could put our ratios into a table. But not like a table like this. We put it into a mathematical or scientific table. We know our ratio was 3 push-ups for every 4 sit-ups. Now, ratio tables are all about equivalent ratios, which means that the ratios all have the same value, or a value of 3 to 4. Well, let's start simple. I know I do 3 push-ups for every 4 sit-ups. So what if I double my ratio? When we double our ratio, I now have 3 times 2, that's doubling. 3 times 2 gives us 6 push-ups. 4 times 2 gives us 8 sit-ups. Although my ratio has changed, it still has the same value because it has a base of 3 to 4. However, ratio tables let you write multiple equivalent ratios. So what if I tripled it? Now when we triple our base ratio of 3 to 4, 3 times 3 gives us 9 push-ups. 4 times 3 gives us 12 sit-ups. Or what if I quadruple it? Now when I quadruple my base ratio, 3 times 4 gives us 12 push-ups. 4 times 4 gives us 16 sit-ups. Now all of these ratios are all equivalent, or they have the same value, because they're all related to 3 to 4. They just have different multiplicative factors. Aren't ratios so cool? Now, ratio tables and T-charts are practically the same thing. Now, this might be super confusing, so hang on. A T-chart. Guess what you gotta do? Step 1, make a T. Then, all you have to do is fill in your blanks just like it were a ratio table. We just start by writing our ratio. Oh shoot, we need a ratio. We need to find 2 things to compare. 2 things to compare. 2 things. That's not gonna work. Well, what if we did how many times I get hit in the body with a dodgeball compared to times I get hit in the face with a dodgeball? Wait, that doesn't sound good at all. Now we have a ratio, at least we know how many times I got hit in the body versus how many times I got hit in the face. That means 2 shots to the body for every 3 shots to the face. Now, T-charts and tables are often used to find equivalent ratios. For instance, what if I were to ask the question, what happens when I get hit in the body 10 times? Now think for a second. What did I do to 2 to turn it into 10? That's right, we multiplied it by 5. 2, 4, 6, 8, 10. Now, to keep our ratio equivalent, whatever we do to one side, we have to do the same thing to the other side. That way we keep everything proportional. So I need to multiply 3 by 5. Now 3 times 5 would give us 15. Both these ratios have the same value because every time I get hit in the body 10 times, that means I have to get hit in the face 15 times. Now, what if I were to say, when I get hit in the face 30 times, how many times did I get hit in the body? Well, let's start here. What did I do to 3 to turn it into 30? Bingo! We multiplied it by 10. But the key to equivalent ratios is whatever I do to one side, I have to do to the other side. So I multiplied my face by 10, so I have to do the same thing to my body. And 2 times 10 would be 20. So when I get hit in the body 20 times, I'm hit in the face 30 times. So T-charts and tables are just a way to help us organize our information. And then we just gotta see, what did I do to my numbers? Can I find a common multiplicative or division factor? Let's try one more so you can see how tables and T-charts are the same. Let's see, what can we make a ratio of? Oh wait, that's easy. I can make a ratio of the marshmallows I can fit in my mouth to total marshmallows I have. I have 25 marshmallows in total. Down the hatch, bon appetit. This gives us a ratio of 20 to 25. Now, does this ratio look simplified to you? No, it does not look simplified. Now, ratio tables and T-charts usually ask us to find the missing values to our ratio. So, what did I do to 25 to turn it into 5? It looks like we've divided it by 5. So, 25 divided by 5 is 5. Okay? Now, whatever I do to one side of my table or my T-chart, I have to do the same thing to the other side. So when I divide 20 divided by 5, it would leave me 4. I have a ratio of 4 marshmallows that I can fit in my mouth to 5 marshmallows that I had in total. What did I do to 4 to turn it into 16? It looks like I multiplied it by 4. Now to keep my ratio table equivalent, whatever I do to one side, I have to do to the other side. 5 multiplied by 4 gives us 20. We're just finding pieces to our missing puzzle. Now that we know this is 20, what did I do to make it 50? Let's look at our simplified ratio. What did I do to 5 to make it 50? I multiplied it by 10. And to keep things equivalent, whatever I do to one side, I have to do to the other side. So if I multiply 4 by 10, that would give my ratio 40 to 50. And T-charts help us accomplish the same thing. They're all about finding the missing pieces to our puzzle and keeping our ratios equivalent. Now that you have a decent understanding of ratio tables and T-charts, why don't you try this one? And we're back. All right, well, let's see if you got it. Now, we have a ratio of 3 to 8. What did I do to 8 to make it 24? Oh, it was multiplied by 3. And whatever I do to one side, I have to do to the other side. 3 times 3 would give us 9. Now we gotta find out, what did I do to 3 to make it 15? Well, to turn 3 into 15, I have to multiply it by 5. Whatever I do to one side, I have to do to the other side. 8 times 5 gives a product of 40. And lastly, what did I do to 8 to turn it into 72? Well, I multiplied 8 by 9. But whatever I do to one side, I have to do to the other side. 3 times 9 gives us a product of 27. Now you could use your knowledge of equivalent ratios to solve tables and T-charts. You keep it up, you rock star.